Okay, so this video is going to look at going through exercise 7D where we're integrating by parts. So once again, we have a function times a function. And this time we can't use substitution because the derivative of one function isn't the other function in there. So we've got this other rule, which is called integrating by parts. And this looks a little bit confusing, but take it easy. You'll see how we do this. So the first thing we're going to do is we can clearly see we've got two functions here. One function is x and the other function is e to the x. Now we have to assign, one's going to be the u function and we want to differentiate that one. So that should be a function that's going to be easily differentiable. And then we're going to have a v function that we are going to integrate. So obviously that one has to be easy to integrate. Now, when you've got x and e to the x, I think both of them would be quite nice. However, x is going to be the winner for differentiating because the derivative of x is just 1. That's really nice. The integral of e to the x is similarly beautiful, and that is just e to the x. Whereas if we had made x the function that we wanted to integrate, the integral of x is x squared over 2, and that's going to be messy. Okay, so now when we write it up like this as well, so notice the positions that I've used. If I'm following this rule, uv, so I do the cross multiply there, and then the derivative of u times v, so then it's just those two times together. So get into a rhythm and you don't even have to sort of think twice about it. So the integral of x times e to the x will be x multiplied by e to the x, right, minus the integral now of the derivative of u times v, so it's these two. So 1 times e to the x. And so that becomes x e to the x, and the integral of e to the x is just e to the x. So that one's done. Now let's have a look at the next one. Similarly again, when we've just got an x, I hope you've now realized that that would be really nice to make that the one that we differentiate, because the derivative of x is just 1. Okay, and we'll let v dashed, that's going to be sine x. And so what is the integral, right, in other words v, what is the integral of sine x? That will be minus cos x. Okay, so once again, when I am applying this rule, okay, u times v, so that's going to be those ones crossed together, so that will be minus x times cos x. Subtract, okay, u dashed times v, so u dashed times v, so that's going to be the integral of 1 negative cos x. Okay, so that's minus x cos x. And now what is the integral? We've got a negative and a negative, so that means positive. The integral of cos x is sine x, so that becomes plus sine x. And don't forget our friend, your friend and mine, cos x. Okay, let's keep going. Let's have a look at C. Okay, when we're doing this one, again, we're choosing our functions. Now, if you look at all of your rules, we actually we can't put ln x here because we don't have any rules that help us integrate ln x. So we can only differentiate. So our choice is made for us. The ln x has to go there. Its derivative is 1 on x. And this time, x squared is our derivative, so its integral will be x cubed over 3. Once again, we're going to follow our thing where we're going to do the cross and then that way. So what do we get? This is going to be, so u times v, so that's going to be x cubed over 3 times ln x minus, right, the integral of 1 on x times x cubed over 3 by dx. Okay, so the first one, that's just sticks as x cubed on 3 ln x. Okay, we're going to simplify this, x cubed over In fact, we'll just pull out the 1/3 there. Okay, x cubed divided by x is x squared by dx. And that's something I can definitely integrate. So that's going to be x cubed over 3 ln x minus, now this becomes add 1, divide by 3, so that's going to be x cubed over 9, because 3 3s are 9, plus c. Okay, so let's have a look at question 2. So we want to integrate ln x. They've given us the hint that we should say 1 times ln x, because when we look at our rules, there is no rule for ln x. Right, we can differentiate it, but we can't integrate it. So if we say let u, right, the u1 be ln x, that means we can differentiate that one to be 1 on x, and therefore we can make our derivative 1 is 1 and v is then x. So once again we're going to do the okay, so this integral now becomes u times v, so x ln x minus the integral of 1 on x times x, and last time I checked that's just 1. So we've got x ln x minus x plus c. Alright, so that's part A. Now let's have a look at part B. It says hence. So remember, we know now hence means try and use what you've done before. So we've got ln x squared by dx. We can't use the substitution because we haven't got the derivative of, so if I let u be ln x, we haven't got 1 on x anywhere there. The parts is a bit of a mystery because we haven't got two functions, except we know that ln x squared is ln x times ln x. And remember, we're wanting to use what we did in the first part. So when we go and we say, all right, let u, once again, we're going to say let u be ln x, and therefore the derivative is 1 on x. Now before, we couldn't say let the derivative function be ln x because we couldn't integrate it. But from part A, don't we now know that the integral of ln x is this? Yes, we do. So that means this is now x ln x take x, and the plus c will sort of go in there when we do the thing. Okay, so again we're going to multiply like so. So I'm going to have to just go down here because I'm going to need a little bit of room. So that's going to be ln x times x ln x take x minus the integral of 1 on x times x ln x take x by dx. So what does this become? Ln x, I guess we could have tidied that up, but anyway, I've kept the brackets. Okay, 1 on x times x ln x, we're going to integrate ln x, and 1 on x times negative x is minus 1. So we might as well expand this now. So we get x times ln x is ln x squared minus x ln x minus, now what is the integral? We're integrating all of that. What is the integral of ln x? Again, it's up here. So it'll be minus x ln x take x. And what is the integral of minus x minus 1? So that's going to be minus minus x, so plus x plus c. Okay, what does this become? X ln x squared minus x ln x minus another x ln x, so that's minus 2. Negative and negative make plus x plus another, so plus 2x plus c.